Well, I think we're live, and I'm pretty sure I put this unlisted, but it seems that Krish has already found it. So, hi, Krish. Yeah, how random. Anyway, one concurrent viewer. That's so random. I swear I put this unlisted. I have no idea how it's not. That just means I can't make a mistake because last video I made a mistake and then I ended up like redoing it, and I just deleted it and started again. But if someone's watching this live, then I guess I can't make a mistake. So I better be confident. Anyway. We're going to look at trig equations. Hi, Christos. We're going to look at trig equations. Now, again, this is something you've done before. It's just that there's more, I guess there's more to it than you might have realized. So, in other words, this would have been a line of working that you would have ended up with if you were looking at triangles. So, I guess if you were looking, maybe I'll draw it. So let's suppose I had a triangle and stuff, and it was right angled, and I knew what two of the sides were, perhaps, and I was trying to find out what the angle was, and then I'd go, oh, okay, opposite adjacent, and then I end up with tan theta equals something, and then what you would normally do in this case is you'd go, okay, well, theta must equal sine inverse of all of this, and then I'd chuck that into the calculator. And yes, that's correct. Now what the calculator gives you is it gives you an angle between 0 and 90 degrees. Now, I guess from last lesson, we've kind of investigated the fact that there's more than just our 90 degrees, and there's more than just talking about trigonometry in terms of triangles and angles just between 0 and 90. They actually extend a lot further than that, and that's why it makes a little bit more sense to look at the unit circle instead. So let's draw a unit circle. I guess we'll draw a Cartesian plane. Draw a circle on it, that's massive. That's y, that's x. And what we said was that any point, we call that xy, or we can call it cos theta, sine theta. Now, if I were to, in this case, if I were to try and work this out, and I'd go, okay, well, theta must equal sine inverse, and you'd still have to do this. That equals, off the top of my head, somewhere approximately around about 49 degrees. So what that's actually given us is on our unit circle, but before you would have seen it as a triangle, it's given us an angle going this way of 49 degrees. So in other words, let's call this green. It's given us this, where that's 49 degrees. Now, the problem with this is, well, that's fine, like that's one solution, but we know that sine is our y value. And our y value, so I've just computed sine, is this value up here. So it's basically saying that at this point on the unit circle, keeping in mind that that's 1, so if that's 1, this point here, like the y value, so this is 0.75. Now, there's actually two places where 0.7538 actually exists. And if I'm looking at this point here as being 0.7, let me actually write that. So this is 0.7538. Then yes, there's a solution here, but there's also a solution here. Is that even? That's not even. There. Okay. Now, because sine is our y value, so remember this is y, there's two solutions where the y equals this. So in fact, this is not the only solution, is what I'm saying. I've said that, I feel like I've said that 1,000 times, but I just want to drill that in. This, where that is also 49 degrees, that's a second solution, and we can check this. So if I go sine 49, so I'm like plugging in my solution, theta is 49. Sine 49, that's around about 0.75. So 0.75. Obviously there's an error because I've rounded. Now, if I were to also go with this angle, which is, so let's write this, also 180 minus 49, which is equal to, okay, I'm not making a mistake here, 180 minus 40, 131. 131, and that's also a solution. So theta also equals 131, and I'll show you. Sine 131 is also 0.75. So this stuff is really, really cool because there's more than one solution. The reason that in year 9 you would have done, or I guess your answer would have just been this, is because you're looking at triangles. You're limited by the fact that I'm looking at a triangle that can literally only have, so these would be less than 90. But if I'm looking for something or an unlimited amount of solutions, I can also look for this point here. Now, it's not going to give me these points down here. If this was a negative, then yeah, this would be negative 0.7538, and that's fine. So, but we haven't looked at that yet. Another thing that I find is kind of interesting. See how we start here and we go around? Well, what's stopping us from going all the way around the circle? So in other words, here's 360 degrees. If I then went again 49 degrees, so also 360 plus 49 degrees, what's that? That's 409. That should also be a solution. So I'm coming around to here. I'm ending up at the exact same point. I've just gone like stupidly around the circle to do it. So if I go sine 409, I've also got 0.75. This stuff is so cool. What if I went backwards? That should be a thing. What if I started here and went this way? So how would I get there? We actually go negative. So this is negative 180 degrees. Let's aim for this one. Negative 229 sine negative 229 0.75. How cool is this? Is so cool. I think it's really cool. I hope I'm not confusing people too much. Okay, now let's combine a couple of things that we've done before. This is, again, something you can just type into the calculator. So I can just go, okay, well, theta equals sine inverse of 0.5. But I guess what you can also realize is this is one of, I can rewrite this as a half. And if you remember from those exact ratios or from my table, I've got a half is equal to 30 degrees. So when you type this into the calculator, you're going to get 30. And if you just remember that sine 30 is a half, then you're good. So I can say that it's exactly 30 degrees. So that would give me this 30 degrees angle here, but my y value or sine is positive here and here. So in other words, 30 and also 180 minus 30, which is 150, that should also be a solution. So theta also equals 180 minus 30, which equals 150. So this and this should both be solutions. So this is kind of like a quadratic equation where there's two solutions. This actually has unlimited solutions. I could go here and also here and also here. I could add like 360 times infinity and it would still give me the same answer. All right, so let's test that. So sine 30, yep, that's a half. What about sine 150? Yep, that's also a half. What about sine 360 plus 30? So 390. Sine 390. Yeah, that's also a half. This stuff is so cool. Now, just got to be careful because the question's going to say something like this. Solve each equation. That's fine. I can solve this. I just take the inverse. I can solve this. I know that this is just 30 degrees. But if it's asking for all the possible acute and obtuse solutions, so acute means I'm looking right here. So then my triangle has an acute angle in it. Acute just means between 0 and 90. So if you're ever asked for an acute solution, it means it's got to be between 0 and 90, so like 49. If it asks me for an obtuse solution, that means it's got to be here, and my angle has to be between 90 and 180. Maybe I'll write that. So this means between 180 and 90, and this means between 0 and 90. Acute and obtuse. Right. If it asks for a specific one, so if it asks only for the obtuse angle, then you would have to say, okay, it's this. Now, we've only dealt with the positive cases. Let's deal with something that's negative. So tan, let me move this up. Tan negative 2.5. So what even is that? Well, firstly, let's just do this. So theta equals tan inverse of negative 2.5. when I type that in. So I can type that in. So shift tan negative 2.5. Okay. Negative 68. Is that right? Is that what I've got there? Okay. This is where it gets slightly confusing. What that's actually giving you, so this is degrees. If it gives you a minus degrees, that means instead of going this way, it's going this way. So it's actually given me an angle like this. So that being 68 degrees, or negative 68, because it's kind of gone this way. Now, I guess what you've got to realize is tan, you've got to think about where that's positive. So sine is positive here and here because it's the y values. Cos is positive here and here because it's the x values. So now you've got to think about where tan's going to be positive and negative. So I guess you just think about where two positives are. So two positives are here, so that means tan's going to be positive there. Now, if cos and sine are both negative here, then two negatives make positives. That means tan's positive down here. Now, I want to know when tan is negative because I've got this negative solution. So that's going to happen when I've got a plus and a minus. So that's why my solution was down here. It's given me this. So your calculator likes to give you the acute angle, but the acute angle doesn't exist up here because tan is positive there. So what it's giving you is the next best thing, which is down here. Now, what I want, because I'm looking for an obtuse angle, or well, it hasn't actually said that, but I guess in year 10, I don't have to teach you the fact that negative angles exist. So I shouldn't be telling you that this is a thing. But I want to, I guess, show you that because I want you to know where this negative 68 comes from. So really it's asking for this angle, but when you come to it, you, I guess, would want to be talking about where it exists everywhere. But let's suppose we're using our year 10 mindsets. I'm looking for this here. So it's basically saying that this angle is 68 degrees. So then what's the acute and obtuse angles? So I'm asked for the acute and obtuse angles. Acute generally means in here, okay? There wasn't a solution in there, we just said that. But here there is a solution, and it's the obtuse solution. If this is, really should have drawn a picture of this. If this is 68 degrees, then I'm looking for my obtuse angle, which is going to be 180 minus 68, which is 12 to 112. I was like, what the hell? Okay, 112. I guess we should test that answer. I'm a little bit worried now. 10, 112, negative 2.4. Have I rounded? Was that rounded? Yeah, it was rounded. Okay, that's why it's kind of close. Round that to decimal place. To one decimal place, no good. Okay, I feel like I should have drawn a picture. Oh well, too late now. Okay, cos x. Now, I really should have drawn a picture. I'm really disappointed that I didn't just sit there and draw a picture. Oh well. Alright, cos, where is that negative? Well, cos is our x value. Our x values are negative here. This negative is going to tell me that my solution is going to be in here, which means it's going to be obtuse. Now I'm looking for an angle between 90 and 180 degrees. So x is equal to cos inverse negative 0.09. Type that into the calculator. Cos negative 0.09. Is that right? Can't be. Oh, I wrote cos. I didn't even write cos inverse. Cos negative 0.09. Okay, 95. Around 95. Alright, that's given me an angle. Oh, that's nice. It's given me an obtuse angle. That's exactly what I want. So I need to know where cos is negative. It's negative over here because it's my x value, which means all these are negative. Now 95 is here, so that means that, hang on a minute, is 95 my answer? Yeah, that was easy. Okay, so that means this is 95. Cool. What's it in degrees and minutes? Who cares? Alright, next one. Last one. How simple does this look? This looks like the most simple equation. It's just equals 1. Beautiful. Okay, let's solve it. Before I even type this in, I want you to think about where this might be. So using my unit circle, where is sine 1? So where is sine, or y, 1? Well, y is 1 up here. So that means what the calculator is going to spit out is 90 degrees. There's an infinite amount of solutions to this, and I'm going to try and write a lot of them. Now, it should spit out 90 for my first one. Let's test that. So sine inverse 90. Okay, it gave me a maths error because I didn't close the brackets. No, it didn't. What am I doing? Why did I do sine inverse? Sine 90. 1. Okay. I wrote it backwards. Okay, that's my first one. Now let's look at this. If I just keep rotating around the circle, I should keep getting solutions. So if this is 90, then what's this? Well, that's 360 plus 90, which is 450. So that should also be a solution. Let's test that. 450. 450 equals. What is wrong with me? Sine 450. Oh my god, press sine. Sine 1. If anyone can come up with a general equation as to how to write each of these in terms of like n, which would be how many rotations around the circle, I'd be pretty impressed. I'm going to give you the negative one. The negative one being this. If I want to get to here, if I go backwards like this, I've got negative 90, negative 180, negative 270. So in other words, negative 270 should also be a solution. Negative 270. Sine negative 270. 1. This is so cool. This stuff is so cool. Now, I guess the last thing I want to tell you is the textbook is going to assume that you know nothing about negative angles and you know nothing beyond 180 degrees. So you'll only be working in here. That's why the questions say acute and obtuse, because acute's going to be here, obtuse is going to be here. But I just want you to recognize that there exists an infinite amount of these solutions because I can just keep rotating around the circle. You just got to keep in mind when there's negatives, you've got to think about where tan is negative, where sine is negative, and where cos is negative. So maybe I'll write that. Let's draw 3 circles. Let's do that. How long have we got? 8:30. 1, 2, 3. Circle, circle, circle. Sine, cos, tan. Now this is my y value, this is my x value, and this is sine over cos, so y over x. Okay, let's get rid of these because I hate that. Now sine is the y values. So the y values are here, that's positive here and positive here, negative here and negative here. Cos is my x values, that means I'm positive there, negative there, negative there. Tan is y over x, so I had 2 positives here. Actually let's do this in black. I had 2 positives here. I've got a positive and a negative, I've got a negative and a negative, and a positive and a negative. So in other words, this here is positive, that's positive, and they're negatives. So when it comes to solving one of these equations, just realize that if I'm looking at tan negative, then I'm looking for something in here or something in here. The textbook's going to assume that you don't know anything about this, so you're looking for a solution in here. If your answer is 45 degrees, that's not right, because you can't have 45 degrees over here. It's got to be an obtuse angle. It's got to be between 90 and 180. But why do we have to give 3 solutions? You don't have to give 3 solutions. Are you referring to this one, Krish? You don't have to give 3 solutions. I just like, a question will specify how many solutions you need. For the moment, you're just giving the acute and obtuse solutions if they exist. So for this question specifically, you need to have given this and this. If the question just asks for the obtuse solution, you just give this. If it asks for only the acute, you just give this. If you're asked a question like this, and it says, give me the acute solution, well, this actually doesn't have an acute solution because cos in, oh yes, no, sorry, because cos is negative here, having a look down here, my acute solution would need it to be positive. So in other words, this doesn't have an acute solution, it only has an obtuse solution. So you'll only have a maximum of 2 solutions at the moment. But when it comes to it next year, you could have infinite. So I could write this list infinitely, positive and negative. Are there any? We've got 2 viewers. Does anyone have a question? I want to do this live, but I didn't realize that, like, for starters, anyone would be awake at 8 o'clock, and yeah, this would be cool to do live. I imagine 30 of us in here spamming the chat. But it seems like Krish is the only one in here, and I did make it unlisted, so I'm super confused as to how you found this video. Okay, nice. All right. I think that's all I've got to say about that. Have a lovely day. I'm thinking about next week doing one live, or maybe all of them. There's going to be 4 lessons next week. So, and there are standard and advanced content. So this is kind of as far as we go in terms of the advanced content, which kind of sucks, but you can see how much further we can go. If anyone finishes up, there's only 3 questions in the exercise. If anyone finishes them and wants me to give you questions that refer to both these and the infinite going around in circles, then let me know, because I'm more than happy to give you questions like that. All right, goodbye.